Hey guys! Alright, today we're going to do section 2, inverses of relations. So the first thing I want to talk about is if you have just a set of ordered pairs, in order to find the inverse it's actually really easy. All you have to do is reverse the order of each coordinate pair. So if I want to find the inverse of 1, 4, 2, 8, 3, 8, 0, 0, negative 4, negative 1, all I have to do is go back through and reverse each of them. So this first point here is going to be 4, 1. The second point is going to be 8, 2. The third point is going to be 8, 3. The fourth point will still be 0, 0. And the last point here will be negative 1, negative 4. Okay, make sure you enclose it in the brackets to show us that it's a set. Alright, next up we have the inverse relation theorem. So this says if f is a relation and g is the inverse of f, we can say that a rule for g, the inverse, can be found by switching x and y. The graph of g is a reflection image of f over the line y equals x, and the domain of g is equal to the range of f, and vice versa, the range of g is equal to the domain of f. Okay, so essentially all that's happening in an inverse is that you're switching the x and y values. And when you do that, you can also basically swap the domain and range, and you can also reflect it over the line y equals x, which is also the equivalent of switching the x and y values. So if I want to find the inverse relation of y equals 4x minus 1, the first thing I'm going to do is switch the x and y values. So I'll have x equals 4y minus 1. Then I can solve for y, so I get x plus 1 equals 4y, then I divide by 4, and I get y equals x plus 1 divided by 4. So this is going to be the equation for the inverse of y equals 4x minus 1. Now we can determine whether or not the inverse is a function. Remember that in order to be a function, for every input you have to have exactly one output. So you cannot have more than one output for every input. And the way that we talked about it before was using our function machine. So if I'm putting, let's say, a 6 in, okay, then the only thing I should get out is one number. I shouldn't be able to get out more than one number. So here, if I put a 6 in, I get 6 plus 1 is 7, 7 over 4. Okay, I'm just getting one number out. An easy way to do it is to graph it. So if you graph this on your calculator, you should get a straight line. Therefore, you know it's going to be a function because it passes the vertical line test. Now we can determine, is the inverse a function? So again, if I put that into my calculator, it passes the vertical line test. So I would say, yes, the inverse is a function. We can also use the horizontal line test for inverses, and this is really useful when we're not able to come up with an equation for an inverse. So the inverse of a function f is itself a function if and only if no horizontal line intersects the graph of f in more than one point. So essentially, when you're graphing the inverse of a function, remember that you can reflect it over the line y equals x, and in doing so, what that's doing is it's essentially just rotating that line 90 degrees. So if I wanted to pass the vertical line test, remember a vertical line is straight up and down, if I rotated that 90 degrees by reflecting over y equals x, it would become a horizontal line. Therefore, instead of actually just rotating the equation 90 degrees, I can instead just think about, if I look at this equation, would it pass the horizontal line test? Okay, if it does pass the horizontal line test, that means that the inverse would be a function. Alright, so if I have y equals x squared, that graph is going to look something like this. So I need to determine, would that pass the horizontal line test? If I draw a horizontal line right here, you can see that it would not. Therefore, the inverse is not a function. Okay? You can do the same thing with these other two problems. So if I have y equals x to the fourth, again, that graph is going to look something like this. And again, it is not going to be a function because it fails that vertical line test. This graph right here, I would just graph this on my graphing calculator. So when I graph that equation, I get something like this. Okay, so again, I need to determine, would this pass the horizontal line test? And the answer is no, because if I draw this horizontal line in here, okay, I can see that it's hitting at more than one point, therefore, no, the function is not, the inverse is not a function. Okay, so all of these would not have function inverses. That's everything for section 2.